All right, are we ready? So this is the topic of our last, this is basically the theme of our last topic here. So solution. One goal is to actually get you to realize that a lot of the questions in the book are pretty much the same question over and over and over and over again. The same exact question. Now, we have done this quite a few times the long way. We now have a shortcut. I told you, do it as quickly as you can. What is that? What was somebody doing when he was writing this limit? Or what were you doing when you were writing this limit?
I was multiplying by tangent.
Well, then you're doing it the long way, right? I mean, you're describing a procedure. You see, here is one other thing. Many of you want to describe a procedure. That's not what you should do. What you should first ask yourself is, what are you doing, philosophically speaking? What are you doing? Like, why are you here? To pass the class, right? I'll tell you afterwards why maybe you're here, but I hope you're here for a philosophical reason, because you want to understand something. Now, somebody that was doing this procedure, he wanted to understand something. What was he trying to understand? He was trying to calculate a derivative of what? So what he was trying to do is calculate the derivative of what?
The line.
Well, the derivative is the slope of the line, correct, right? It's the slope of the approximating line to the curve. But the question is, what was the function that we were trying to calculate the derivative for? Square root of x. And he was doing it for a particular x. X was 4. Now, that's why you learn shortcuts. That's what you were telling me. Why not use a shortcut? So a shortcut here is the derivative of x to the power of 1/2. Where x is 4. And what is that? This is 1/2 x to the power of minus 1/2, where x is 4, which is simply 1/2 times root of 4, 1 over root of 4, which is simply 1 over 4. Correct? That's the answer to number 1. You see, there is algebra that you can use here. There are a bunch of things that you can use here. But the first thing is, I want you not to think that you're in a factory. You ask yourself what you're doing, why you're doing it, what's the concept, what's the idea. If you can answer this question, you will not only pass the exam, you understand, you master calculus. You can use it for something. Number 2. Now, number 2 looks very similar, right? Very similar. Obviously, you don't want to do, again, some long procedure here. You want to think about it. Now, how do you think about it? Now, again, there is a joke that I have repeated quite a few times, but it seems relevant here. So you have a mathematician and engineer. They're stuck on an island. And on the island, there are 2 palm trees. Actually, 1 palm tree, why not? And on the palm tree, you have coconuts. So first, it's the engineer's turn. So the engineer climbs, brings down a coconut, and they eat. Now it's the mathematician's turn. What he sees? He already sees that the problem was solved. So he takes the engineer, places him on the palm tree, thereby reducing the problem to a previously solved one. You understand? No. All right. If you don't understand, then this is already a solved problem. This is already a problem that we solved. But it's slightly different. This is a plus h, this is a minus h. So what is the derivative? The derivative is basically what you have here is a function at the value a plus something that vanishes to 0, and then you divide by that same something that vanishes to 0 at the same exact rate. Then you know it's the derivative. So here is the $1 million question, or not a little bit less, but definitely along the way to the $1 million question. You see, and that's called wishful, I call it wishful thinking. What do you wish to have seen here So I'm going to write here 4 minus h minus root of 4 divided by, what do you want to see here? If you can answer this, let me give you a hint. Root, I'll give you this hint. 4, you want it to be plus something that goes to 0. You see, you look too much at the h, but you should not look at the letters, you should look at the meaning. And the meaning is 4 plus something that vanishes to 0, in this case plus minus h, minus root of 4. Now I told you what you want to see on the bottom. Precisely. You have won the $1 million question. Congratulations. So you want to see here a minus h. But what you see here is h. How do you modify this to now be the answer that you want it to be? You said you want a minus here. So you place a minus. How do you compensate? I divided by minus 1. I have to multiply by minus 1. You understand? So what you now have is, what do you have now? Very quickly, what's the answer?
Negative 1/4.
Negative 1/4, wonderful, right? It's pretty much like before, now it's negative 1/4. You begin to understand the idea? Right? The goal is, again, I want you to recognize when you see something that looks like somebody was doing the derivative. And you don't read the letters, you don't read the h. What you read is, it's 4 plus something that vanishes to 0 divided by that something that vanishes to 0. You see, you have the difference of the function at a plus some, basically this counterfeit 4 minus the actual 4 at the function. So this is minus 4. Now, while we're at it, so how do we do number 3? Now it should be simpler. So what is number 3 then?
You have to multiply by h.
Yes, very good. So for this to be the derivative, it has to be 4 plus, in this case, the something that goes to 0 is written as h squared, right? If h goes to 0, h squared goes to 0. Divided by, we have here h. What I want to see here is, I want to see here h squared. So to get here h squared, I have to then multiply by h. You see, I divided by h, I multiply by h. Now, what you have is limit of two quantities. The limit of h as h goes to 0 is, what's this limit here? By the limit of product, this is 0 times, what's that? First parenthesis is 0, because the limit as h goes to 0 of h is 0. What's in the second parenthesis? No?
I have a question.
Yes.
Why didn't we simplify it before we do it?
I mean, simplified, this is very quick. You can do something else, but then you miss the point. The point is to look at something and just right away see what it is. You can try other ways, right? On the exam, you're not penalized for doing a question another way. But my point is, you want to avoid being in a factory. You say, avoid doing this. Avoid pressing buttons. So I press a button. I don't care what it does. I'm going to press it because that's what I was told to do. Avoid that. What's going to be here? Again, you stare at the h. But that means that you are not thinking about what the limit is. This is the derivative y. What's the form of the derivative? It's the value a of the function plus a perturbation. Perturbation is something that melts or vanishes to 0. And then it has to be divided by that same perturbation. So whenever you see something that goes to 0 divided by the same something that goes to 0, you see this form, you say, aha, it's a derivative. Why did I put the h squared here? precisely because the perturbation here was of the form h squared. So what is this? Be brave. What's that? No?
Slow 1/4.
1/4. Yes, it's 1/4. It's exactly the same thing. Look at this pattern, look at this pattern, look at that formula. It's exactly the same thing. This is 1/4. And the result is 0. Okay? Wonderful. Now number 4. You see, I make the pattern less and less recognizable, but slowly, to try to train you to just quickly pick it up. If you look into your book, look at most of the problems there. It's really just taking the derivative. You can solve them like this, like in a second. If you see it the right way. Understand? If you see it the right way, you can just go like this. But if you don't see it the right way, it will be forever.
So then the test is going to be like that also?
No, I mean, honestly, in my opinion, the test is the same question repeated over and over and over. But maybe you will disagree. My goal is hopefully to make you not disagree. So, what would you have liked to see? This one is a little bit slightly more involved. You can actually begin seeing it much faster once you learn stuff. So, and by the way, as I mentioned, nobody, by the way, followed it through. Did I mention that, watch Feynman? I sent you video lectures for Feynman. He's a very, very great physicist, very interesting guy. Listen to him. It's very inspiring. Read his book if you want to. You can see what this guy was like. For that, if you do and show me that you actually read it, maybe I will give you like 10 points extra. Right? Just anything to save you. I don't know. So what do we have here? So you see we have here 4 plus h minus root of 4 minus h. What you're not happy about this formula? What would you have changed to make it very simple for you, based on what we just did? Well, I mean, if you could just change this question a little bit, what would you have preferred to see here? Like, are you happy with this part?
Yeah.
Are you happy with this part? No, here you go. So you see what you don't like. What would you have liked this part to have been? No, I mean, what would you like to see here? I mean, you don't like the problem. Change it to one where you would be happy. What would you like to see there? Square root of 4. We just have it over there. Square root of 4. Right. Right. Don't be scared, right? Here's a problem that you just solved. You want it to be a problem that you just solved. That's why you reduced it to a previously solved one. So what you want here is root of 4. So that's what you are guided by. If you recognize what you want to see, you can solve a problem. You see, that's the thing. You need to know what you want to see there. So what you see is 4 plus h. And then I'm going to write what I don't have here. And of course, I cannot change the equation, so I cannot change the formula, so I need to add it back. And here we have minus root 4 minus h. Divided by h. Okay? So, now I can break this limit into two parts that are more or less similar. So I can take it and write limit as h goes to 0, radical 4 plus h minus radical 4 over h. And here I have plus. By the way, I'm a bit lazy. Will you forgive me if I write here something more than a plus? What I mean, you look at this thing. I don't know. No, I guess I cannot be lazy. Okay. So root 4 minus okay. Do you see this? Do you see up to this step? What now? So this is limit as h goes to 0, radical 4 plus h minus radical 4 divided by h. What can I do here? What change do you want to make here? Yep.
If you make it into radical 4 plus negative whatever, then switch them around and then multiply.
Precisely. Switch things around. And by the way, I'm going to do it. I got a little lazy here, so I'm gonna do all the switching around very fast. So I'm going to write here plus, and here I write 4 minus h minus radical over 4, and here I write minus h. So what I have done, I have factored this minus 1 and placed it in the denominator. Or if you prefer, I multiply the numerator and denominator by minus 1. Multiplying the numerator by minus 1 gives me radical of 4 minus h minus radical 4. And multiplying the denominator by minus 1 gives me minus h. Now in this form, look at it carefully. The first guy is now 1/4. Agreed? The first guy is 1/4. We just already solved it at the very beginning. What's the second guy?
0.
What?
0.
No, it's not 0.
Minus 1/4.
No, because it's minus h and here is minus h. What is that? 1/4. It's again 1/4. So the answer is twice 1/4 or 1/2. But what's important, it's twice the derivative. So if you look at this form, it's always going to be twice the derivative. Yep.
I'm just a little confused. Where you first start the solution, so number 1.
Number 1.
Where did you? It says right there. It says 4 plus h.
It's a root of 4 plus h minus root of 4 over h.
How did that turn into square root of x?
Because I look at it and I realize that it's a definition of the derivative. What do I do when I calculate the derivative? I do this procedure. I have f of x plus h minus f of x divided by h, a limit as h goes to 0. I recognize that, you see, what you do, you recognize when the procedure was already some further steps into its solution. So I recognize that this is f of x plus h minus f of x over h, where f of x is radical x is 4, okay? And of course, you should also understand why would somebody do this procedure. That's because somebody was trying to find possibly the slope of the tangent line. Right, if you think, by the way, guys, what are you studying? You are studying here conservation of energy. You're studying a conservation of momentum. All those things are mathematical laws, calculus. What is force? Force is second derivative, right? Basic acceleration is second derivative of position. So if mass is constant, force is mass times the second derivative of your position, of the particle. You are studying laws of calculus. That's why it was created. Okay.